Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation, and we're going to use the power, constant, and sum rules. We're going to differentiate each function with respect to x. So if I was given this function, y equals 2/3 x to the fourth plus 5x minus x to the negative 1/3. Okay? So this one, I'm really using the sum rules and the power rules. All right, so power rule. So what we're going to do is use a power rule for basically each section here, each term. So when I take my derivative, dy dx, I'm going to kind of think of the power rule of each part individually. So this first part here, 4 comes out front, 2/3, right, times x to the 4 minus 1 power. Plus, power rule here, there's an exponent that's 1 there, so we have 1 times 5, x to the 1 minus 1 power, minus power rule here again, negative 3 comes down up front, negative 3, okay, times x to the negative 3 minus 1 power. So now let's simplify all this, right? We're going to simplify each part. So derivative dy dx is equal to, well, 4 times 2 is 8, so we have 8/3 x to the 4 minus 1 power, which is 3, plus, well, 5 times, or x to the 1 minus 1 power is 0, so we have 5 there, so it's 5x to the 0th power, in a sense, and you eventually won't be writing that. Okay, now we have a minus a negative 3. Well, minus a negative is plus a positive, so we have plus 3x. Negative third power minus 1 is a negative fourth power. Okay, so now I have to rewrite this as one final answer. Now, people will debate whether to leave the 8/3 out front or make it a fraction. I'll keep it. I'll make it into like one big fraction, combine it in my last step here, but that's really up to you and what your teacher really wants. I wouldn't care. So dy dx is equal to, simplifying this, well, 8x to the third power over 3, plus x to the 0 power is just 1, 5 times 1 is 5, so 5, plus, now we have x to the negative 1/4 power. I don't like having negative exponents, so I'm going to bring it down to the denominator. So we have that x to the positive fourth power, but the 3 stays up top, and there we have it. We have our derivative here, which is dy dx is equal to 8x to the third all over 3 plus 5 plus 3 over x to the positive fourth power. So let's recap. We're given y equals 2/3 x to the fourth plus 5x minus x to the negative third power. I use the power rule for each part individually, leaving me with 4 times 2/3 x to the 4 minus 1 power plus 1 times 5 x to the negative 1 minus 1 power, or sorry, x to the 1 minus 1, not negative, minus a negative 3x to the negative 3 minus 1 power. Okay, simplified that, got 8/3 x to the third power here, plus 5x to the 0 power plus 3x to the negative fourth power. Okay, and the double negative subtracting negative made it a positive plus positive. So now when I simplified, I decided to make it in each part in one big fraction, or one fraction for each part. So we have our final answer here, which is dy dx is equal to 8x to the third over 3 plus 5 plus 3 over x to the positive fourth power. Got that positive exponent, and the x to the 0 power became a 1, so we can set a 5 there. And there we have our final